Okay, this question is a little bit difficult because there's a little bit of a trick to it, so we need to consider at the end. What we've got, we've got three uh, spots, and they're looking at the height of Uluru, and they get the from different places. So from due north, when they look at it, it's got an angle of elevation of 26. Then they move to another point B, which has got a bearing of 28, and then if they move due east, so 90 degree angle there, when you look at it, that would give us an angle of elevation of 30 degrees. So we've got three triangles there, and all something to do with the height of Uluru there. And what we want to do is determine this bearing of B. So if that's due north, basically we want to work out what's that angle going to be. So the angle AOB. So that will give us the bearing. So we have a look here. Consider the third triangle, and I suppose if you want to look at it in that way, where we've got the height there and to the point C, and it's angle of 30 degrees from the base to the top. We'll just let that be H, so just to get it in some sort of form. So we can write tan of 30 here as H on OC, or OC would be H cot 30. If I draw up the other two triangles the same way, I get OB as H cot 28 and OA H cot 26. It's pretty much the same. It's just the same. It's the same triangle, just different angles of elevation. Now consider the big triangle here, this AOC. So you're looking straight down on it, basically. So the angle that's due north there, and that was due east. So and remember, this is the angle we want to find here, because that's going to be our bearing of B from the north there. So what we can do, if we can get OA here, because we've got a right angle triangle and OC, I know I can say the tan of phi there would be OC on OA. So the OC is the opposite on OA. So from we had here the H cot 30 over the H cot 26, the H's cancel, and we get cot 30 on cot 26, which is the same as tan 26 on tan of 30. Take the inverse tan of all those, and we get that angle being 40 degrees. So that's a start. I know that's going to be 40 there, so I can start to play around with it. I do know now that if I look at this triangle, with this alpha that I want to find, so I've just drawn up this triangle here and playing around with that. This sine of, I've got OA, I've got OB, and I've got the sides opposite, so I can set up the sine rule. So sine of alpha is equal to H cot over H cot 26 is equal to sine of 40 on H cot 28. Again, playing around with it, and I can, and the H's again cancel. I can take the cot 28 becomes tan 28, and multiplying by cot 26 become dividing by tan 26. Gives us sine of alpha being equal to that. Now, taking inverse of sine of alpha there, if you put it in your calculator, you get alpha would equal 44. Now, what we need to do is consider this triangle, and here's the trick. Because that's 90 degrees there, because that's the point A, and that was the point C. If I take that value of alpha would be 44, that would only give me 84, which means that one would be over 90. Now it can't be over 90 because it's part of 90 there. So I know my angle I'm going to find in here has to be acute, which means if that's acute and that one's acute, well, it doesn't mean this one can't be acute, but that can't be 44. It doesn't work. It needs to be larger than that. So it needs to be the obtuse angle. Now remember, sine of 136 would give us that same value. So it's going to be an obtuse angle in there. It's going to be 136. So there's the trick to this one. Realize we can't have 44 there as an angle, because that will give us a bearing of over 100, which can't work. It'll be all the way down here, which has gone past. So the bearing then, the value for theta that I want to find in here would be 180 minus the 40 minus the 136, and that gives me a bearing of 4 degrees. So there's the trick. Just be careful of something like that, because there's a definite trick there that we've got to be making sure we don't make a mistake with.